Warning: electrical shock hazard. The following video tutorial deals with live mains voltage. Physical contact with mains voltage will cause severe electric shock which is harmful and can be fatal. Please do not attempt this at home if you are not familiar in dealing with live mains voltage. Hello folks. Have you ever wondered if AC power is present in your power strip board or not? Especially the one without a red or orange indicator light that lets you know? Or whether your power strip is working or is it faulty? Here, I will show you a simple LED mains indicator circuit you can build using readily available components. You can have this circuit built into your strip board. Or just use it to test your strip board, extension leads, and even the mains outlet to know whether AC power is present or not. Please do note that you must not touch any exposed wiring when in use. Keep in an enclosed casing or insulate all exposed wiring adequately to avoid electric shock, as the circuit will be connected directly to the mains AC outlet. Here we have a familiar household 18 to 36 watt fluorescent light starter. Use a screwdriver to gently take apart the starter. I have a couple of failed starters that I have replaced. Inside the starter is a starter bulb, which would be the failed component, and the RFI suppression CX capacitor, which is the component that still works, and is one that we will be using in our circuit. We generally have these two types of CX capacitors. This type is not that good for our purpose and is more likely to fail, compared to this, which is more appropriate for our use. Now, let's test it to see if it's still good. (5,477 picofarad, or 5.5 nanofarad. A value of 5 to 6 nanofarad is perfect for our circuit design. Now for our list of components. We have the 5.5 nanofarad CX capacitor, a 3 mm LED, a 2.7 kilo-ohm resistor. A quarter-watt resistor with a value of 2 to 5 kilo-ohm should be adequate. And, finally, a 1N4007 diode. Now, let's connect the LED and the 1N4007 diode. LED cathode connects to anode of the diode and LED anode to cathode of diode. The diode is used as a flywheel diode to protect the LED from back EMF. Connect the CX capacitor to the anode of the LED. And then, connect the resistor to the cathode of the LED. Our circuit is now complete. The rest of the components can be found on old mobile phone chargers. 3 mm LED, resistors, 1N4007 diodes, we now connect our circuit to an AC cord and plug. Connect the active wire to the free leg of the CX capacitor. Then, connect the neutral wire to the other end of the resistor. After completing all the connections, plug it into the mains outlet to test. Please remember to never touch, or come into contact with the naked connections we've just made, to avoid electric shock. Testing it a second time. Now we can see that it is working perfectly. Through the camera, we can see that the LED is blinking rapidly, but with the naked eye, it will just be a normal steady glow. Let's test to see the total voltage, and also, how much voltage is being dropped across each component in our circuit. Total AC input voltage is about 244 volts. Voltage drop across the CX capacitor is about 243 volts AC, almost equal to the total input voltage. Voltage drop across the LED is 1.7 volts AC and the voltage drop across the 2.7 K resistor is 0.9 volts AC. The total AC current pulled by this circuit is just 3 mA, which then gives us a total power consumption of 732 mW. In the next video I will have this circuit built into a strip board. Thank you for watching and I hope you enjoyed this video.